Welcome back, everyone. Last time you saw this, the thermistor had broken. I've rebodged it. In fact, I'm just going to say something. I may not upload that other video. It was kind of long. But if you guys want it uploaded, I'll upload it, but I'm probably not going to edit it much. I kind of got this printing, or starting to do the physical print. I'm not sure if you can see here, but there's a little bit of PLA fuzz left on here. It started to print, and I was getting PLA through it just fine without hardly any force. So this little extruder here would have been, extruder motor would have been fine. But the issue right now is that either the hot end isn't staying hot enough to keep it to flow through, or it's getting too hot and it's allowing the plastic to solidify up in the heat break. And what's happening is inside here in the throat of the heat break. If you leave it alone and on and not doing anything, not pushing plastic through, somehow it just hardens in the top of the heat break. So either it's too hot, but not hot down where it needs to melt the PLA or something, I don't know. That part is beyond me. So I'm just going to add another clamp to this temporary camera mount here, just to be sure it doesn't drop you on the floor. There we go. You're now attached to the printer frame. So any vibrations or anything like that you should be hearing, actually. And we are going to fire up the dry run here. Put that on dry run. And there's the test shape on the slicer. Okay, so last time we ran this, you guys saw it on slow, and it was doing about 10 or 15 millimeters per second for the outsides. So now I'm going at about the 3/4 of the theoretical speed, and that's going to be 40 millimeters per second, and we'll see what happens. I haven't tested this yet, so we'll have a go. Okay, dry run is turned on. Okay. It's actually quieter. Isn't that interesting? I don't know how that's coming across to you guys, but to my ears, I'm actually going to try and straighten you out a bit. To my ears here, it's actually quieter in person than the previous. There's a little bit of high-pitched noise from the Y stepper down here. You're mostly hearing the Y stepper right now. But there's no structural sound. I'm not hearing bearing noise or anything like that. Now, I don't think you can see in this shot, but there's a little bit of a dark line where the V-groove bearing touches the aluminum, and that's creating aluminum oxide, which is actually harder than the aluminum. So in theory, it's making a harder spot to run on. But, wow. Okay, now we're up off the bed level. We're actually into layer 2 of the print, so it's actually doing a cylinder and a box, or a cylinder in a square sort of shape. That's pretty fast. Now, if only I had the flow of PLA to support that. That's pretty quiet. I really expected it to be noisier than that. That's pretty quiet, eh? Yeah, like, that's four. Yeah, that's almost, it's 3 times the speed I run the Fabricator Mini at. Sorry, I was just talking to my wife there, guys. That's 3 times the speed that I usually run my Fabricator Mini. And it's about the same volume as my Fabricator Mini without the chamber doors on. As I made a mod that puts doors on the Fabricator Mini to make an enclosed printing volume. Or this here is open. I mean, technically the whole frame is a giant resonator. Yeah, I could add weight to the frame to make it quieter, but I have no idea how the microphone and this camera is picking it up, because you're actually on a piece of wood that's clamped to the bottom of the y-axis. And wow, we're halfway through the test print already. So yeah, that's interesting. I'm just going to pause this here, cancel a print, and then I'm going to restart this dry run at a faster speed. So I'm just going to pause you now. Okay, so we're going to continue on. I just resliced for dry run. The print speed for perimeters is set to 60 millimeters per second, and infill type objects are going to be done at 100 millimeters per second, which is quite fast, especially since I've been used to a Fabricator Mini. So let's give this a shot now. That's going to home. So that's homing now, and then we're going to see it start in. Wow. I don't know if you guys can tell, but actually running at this faster speed, it's quieter. And I can see, because of the scar from when I tried to actually print this onto the tape, it's doing the proper path. I'm not hearing any. The stepper motors are still ice cold. I dare touch a driver. Yeah, the driver chips are ice cold too. So, wow. And of course, Z-axis is irrelevant. There's not much travel on that. There's 400 millimeters of Z in this printer, so in theory I could print a vase or anything like that once I get it going. But as one of the fellows I follow online, Dirk Rendifer, said, and I really hope I pronounced your name right, that it seemed to be pretty quiet. And I got to tell you, there's no vibration in the X. That carriage weighs so little. It really does weigh so little that there's no issue. Also, I wanted to do this because I'm watching how the thermistor is reacting down there. It's working good. I did a little tweak, if you see, I don't know if you guys have noticed, but the heater block is on a bit of an angle to release some of the strain where it comes up here to the mounting point that holds the wire. I don't think that's making a big difference, but I had to resolder the thermistor. I opened it up, and that cheap Chinese thermistor, there was no crimps or anything like that, no moret or little, I can't remember what things are called. There's no little crimp connections folded back. It was actually just soldered. So I tried soldering it onto some spare wire of about the same gauge to get it back up to the same connector, and soldered that up. And I checked it with my meter, did a quick sort of calibration versus room temperature and my body heat using another thermometer, and it seemed to be reading fine. Both this and the heat bed are reading the same ambient temperature. In this corner of the house, it's 19 degrees C. Now, funny enough, as this head gets moving, it's something under 19 because it drops down to 18 every now and then. So it must actually be getting some cooling on the head from air as it's moving through it. That's weird. But yeah, all that seems to be fine. And yeah, it's moving pretty good. So that's at the default Marlin high speeds. That's 60 for perimeters and 100 for infill. Let me just see here. Yeah, according to Slicer, the infill speed is 100 millimeters per second. And basic print speed and outer perimeters are set to 60 millimeters per second. So that's pretty cool. We've only got 5 layers left. It's only a 25 layer test. So now I know I'm only doing a small print in a small area. So what I'm going to do, I think here, is in a couple seconds, I'm going to pause this and I'm going to magnify the XY size. I wanted to see the small movements, like how it was doing, like the small left to rights, how it was handling that. So what I'm going to do is I'm going to try multiplying the physical size by 4 and see how it does with the larger movements and if we're hearing the same sort of sounds. Again, the motors, oh, no. The Y motor is just coming up to above room temperature now. In fact, parts of it are still cold. The X is still mostly cold to the touch. That's pretty good. The drivers, yeah, they're cold. The heat sinks on top of the drivers are cold, so that's pretty good. Again, these steppers came from a recycle, so that's done. Wow. These came from a recycled 3D printer, and I ordered them from a fellow offline when he scrapped his printer. Those are that's where those stepper motors came from. So now what I'm going to do is I'm going to quickly go into object placement. I'm going to scale everything by 4 and make the Z height stay the same height. We don't care. Actually, we're going to keep it short. Slice with slicer. Okay, so we're not going to run this full. We just want to see how the first part goes because we're not doing 22 minutes. Make sure we're in dry run still. So we'll try this now, and then we'll call it a wrap. So this is at 60 for perimeter for printing, and then it's going to be 100 for infill. Wow. I'm going to quickly check Marlin for the speeds. Make sure I don't have something like a maximum speed set that Marlin's overriding, because it'll do that. You can set a higher speed in your print controller, but Marlin will run up to its maximum speed, not even tell you. It'll just be running at its maximum internal speed. So let me just jump down to that. Because when I'm building and messing around with stuff, I'll quite often put a slower speed. Alright. Now, I have the maxes programmed for 200, so I don't think we'll ever be getting near that. That's pretty cool. And it's quieter still. I don't know if you guys can hear that difference. Running actually faster. It's quieter. Well, that's 100 millimeters per second on that non-printing move. Oh, it's catching there. There we go. Watch that. I don't know if you can see that, but the nylon covering on the. I thought I was getting some judder, but it was the nylon covering on the power wires for the head is rubbing on something there. I can't really move it out of the way at the moment. So I'll have to come up with something for that. But yeah, that's printing at 60. For me, that's a big jump up from the Fabricator Mini speed, but it's pretty quiet. I suppose I could try and push it faster, but I don't know if you guys were catching it on the video, but there was some, what looked like, you can just sort of see it, what looks like a little bit of a vibration, but it's actually being caused by the sort of snakeskin wire loom stuff that I've got over the power wires for the heat block, rubbing on the side of the printer. And if I hold it with my hand, it goes away almost completely. But you can also see any vibrations in the belt down here. So at some of the faster speeds in the circle, there were some vibrations. So until I can actually do a print and see if there's any ringing or anything like that, I would say there's no problem with these higher speeds. Yeah, X motor is actually almost still a little bit colder to the touch. Yeah, Y is still cold. Yep, the Y motor is still cold. The drivers are still cold, so that's not bad. Anyhow, this video's gone a little longer than I intended. Mechanically, the moving and all that is fine. I do believe, even though it's a small stepper with the current that it can handle and whatnot, driving the extruder, there's plenty of pressure. I found an extruder stepper motor which has got about 3 times the amperage / torque apparently, that I can just bolt right on and direct replace that. But that'll, if I ordered that now, it would probably take several months to get here because of the holidays, and ordering from China to Canada right now is, oh gosh, who knows. It's on the never boat. Yeah, I'm pretty sure that would have plenty enough pressure if I could just get that hot end to stay hot the way it should and not jam up in the throat. But geez, that's working pretty good by my eye. According to the print preview up in Repetier Host, the first layer of the square part is totally done, so now it's filling in the circle. And it's going quick. So we've already seen the infills. I'm just going to pause this for a second until it gets up into a few layers. Yeah, that's going to take a while to get through to the other stuff. It's remaining quiet even the larger moves. We know it's going to do the infill fast because I printed the same speed at the smaller shape and got it. It did the infills. Here, I have pretty much using Tom's. I have no idea how to pronounce his last name. Tom Sinlander, but Tom's suggestions for filling out Ramp's basic settings for a new printer. So, you know, max speed is set at 200. It's got modest acceleration, modest jerk. So until I can start getting some plastic through this and we can start printing stuff like the Benchy and whatnot and seeing how that comes out, I don't know what else to compare now except for that it's pretty quiet. I'm not fighting to talk over it. In fact, if I just walk around the corner into the other area of the room there, it's hard to discern this running from the freezer it's sitting on top's pump. So that's pretty good. Now, if only I can get the hot end to start working, I can do some PLA. I have a feeling the protection in the ATX power supply that I've modified is detecting this bed as a dead short because the resistance is not right. So I'm going to try flipping rail 1 power 12 volt rail A for rail B and see if rail B can drive this bed and if A can still run this, because they're both, it's supposed to have about 18 amps on both sides of the rail. It's a pretty big power supply, but as you all know, they can lie. So yeah, that power supply might be pushing it. Now I could just run two ATX power supplies side by side and feed two 12-volt sources. I'd like to avoid that, but I do have another spare old ATX. I also have a pretty high-end spare ATX power supply that I was trying to save for something else, but it's actually old enough now. I don't think it works with new motherboards, so maybe that one's going to get harvested. Anyhow, this video is about 20 minutes long. It's longer than I expected. This is just up for those of you that were interested to see the motion and the level of noise, and to watch the mechanics moving. The mechanics of the original part and the idea of this L-channel rail for the X carriage at least is fun. I am not in a position at the moment to do try doing the verticals or the horizontals. There's no reason why you couldn't do them on that. And I will eventually get into a design you could do the Y on those as well. The other nice thing about these rails, and that is if the head was to come down and hit too far, the top V-bearings will pop off the rail, which would allow the whole head to tilt back. So actually, if you crashed this head, it would crash in the typical sense, but it would also disengage from the rail. If it's near the middle, the flex would allow it to pop off, and then it would be somewhat loose, and you won't have caused a lot of damage, although there's not a whole lot that you could do to these anyways, and the parts are pretty cheap, but that's just one bonus of the tiny bit of flex that is in the middle of the rails. Anyhow, I just want to say, if you got any comments or whatever, don't hesitate to leave them below. Some of the users and friends of mine have been great help so far with the hot end issues, so go ahead, comment below. Don't forget to like, and well, if you don't like, go ahead and do that if you want, but it's good if you like. And as always, thanks for watching, and I'll catch you in the next video. And I may upload the troubles that I had earlier. But for now, I'll see you in the next one. Thanks. Bye.